Okay, in today's video, I am going to show the agenda for the day, just in case anybody misses this lesson. If you miss the lesson, we will go over some syllabus highlights. You do need to look over the syllabus that can be found in Google Classroom. I do intend on having you guys take notes every time we do one of these videos, or we are meeting in person, or not in person, but video chat. Your assignment after today's lesson will be a quizzes assignment. You can also find the link for the quizzes assignment in Google Classroom. That should have already been sent out to you guys, and I know some of you have already signed up. And then you're also will be doing watching the video for the next lesson and taking notes, so that when we meet with each other synchronously, we can discuss the notes and do a few extra problems to make sure we have a good understanding. So today we're going to look over solving simple equations. And so what you'll learn is how to solve an equation using addition, subtraction, multiplication, division, and using those to solve some real-world problems. Now, you should have had some of this in 8th grade, so this may be reviewed to you guys, which is good. I'm going to jump to this piece here where we talk about evaluating versus solving. And so you should have learned PEMDAS in middle school. And PEMDAS, if you remember, represents parentheses, exponents, multiplication, division, addition, subtraction. And that is the order in which you go when you're evaluating a problem. To solve a problem, we're going to go in the reverse order. And that basic idea is talked about here in the notes about inverse operations. So if you use the opposite operation, you can cancel something out to help simplify the equation. And they show us something similar here in our core concept, where they talk about the addition property of equality. So if A and B, an equation A and B are equal to each other, and all we do is add C to both sides, because we added it to both sides, it's still an equivalent equation. And so the same thing goes for subtraction. If A equals B, and all you do is subtract a C on both sides, as long as you're doing the same to both sides, we still have an equivalent equation. So we use that, and let me pause for 1 second, and that is also a suggestion to you when you're watching these videos. If I'm going too fast through any of this material and you would like to write more of it down, by all means push pause and write it down. I will go a little faster through the videos just because we don't want an hour-long video. All right, so example 1 here. We're looking at x minus 3 equals negative 5. We always want to solve for the unknown. The unknown will be represented by a letter. In example A, the unknown is x. And right now, x has nothing in front of it, meaning that it's positive. So I'm not going to want to move the x, okay? But I want to get rid of the negative 3. And so if we have x minus 3 equals negative 5, the inverse operation that would get rid of the negative 3 is addition of 3. On the left, negative 3 and 3 become 0. On the right, you're just adding 3 to the negative 5, which gives us negative 2. And we can confirm that by substituting that back in. So if we take negative 2 minus 3, we verify that that does equal negative 5. And so we're good. All right. Next example B, we have some decimals here. So what's our unknown? The letter Y. Y is positive already. So we're going to subtract the inverse operation. Your operation is addition of 2.8. So the inverse operation, which will cancel it out, is subtraction by 2.8. It's an equation, so both sides have to be equal. So what I do to the right, I have to do to the left, or vice versa. And so we have 0.9 minus negative 2.8. And so 0.9 minus negative 2.8 is a negative 1.9. And we can verify that because if we take negative 1.9 plus 2.8, we get 0.9. All right. Let's look at a couple more examples. Typically, this monitoring progress I will leave alone, and we will do this during our synchronous time. But because some of you may miss today's lesson, I don't know why you'd miss it, maybe some confusion or weren't able to get online on time, we'll go ahead and cover all of these. So the inverse property of plus 3 would be what? Minus 3. So we'll subtract 3 from each side, and we get x equals negative 10. The inverse property of subtracting 1/3 would be adding 1/3. And so we get g equals negative 1/3. Remember, when you add or subtract fractions, you need a common denominator, and we have a common denominator in this situation. So all we're adding is the numerators. So a 1 and a negative 2 gives us a negative 1. And so that's where we get negative 1/3. All right, next problem. Inverse operation would be subtracting 3.9. We have two negatives on the right-hand side, and so that'll end up combining together. And so 9 and 4 make 14, right? And so we'd have 1 up here, and so we get negative 10.4 equals P. Or if you want to write that as P equals negative 10.4, that is also fine. All right, so very similar idea using inverse properties. The opposite operation will cancel the other operation, but with equality here, so as long as you're doing the same thing to the left as you do the right, then it's still equivalent. Same thing on the left, dividing by C on the other side, we still have an equivalent equation. So whatever we do to the left, do to the right. All right, so here in example 2, what operation, what is our unknown? N. Now, some of us will look at this as a negative n, and some of us will look at this as a negative 5. The reality is, if I have negative n over 5, or I have n over negative 5, it's the same thing. I personally would treat the n as a positive because in the end, I want my n, my variable, to be positive. So when I'm doing this, I'm going to multiply because I want to use the inverse operation of division, multiplication. I'm going to multiply by negative 5 on both sides. In doing so, on the left, because these are inverse operations and they're both positive or both negative, a negative times a negative is a positive, leaving us with a positive n. And on the right, when you multiply the two negatives, you get a positive 15. And we can confirm that because 15 divided by negative 5 is negative 3. Now, some of you may have chosen to multiply by 5. So if I were to, and I'll do it out here, if I had negative n over 5, if that's the way you perceived it, equals negative 3, then you would have multiplied by a positive 5. And in doing so, again, we have inverse operations. These, let me get a different color. These would have canceled each other because one's multiplication, one's division, but the negative would have been left on the n, giving us, and we would have a negative 15 on the right. Are you technically right? Yes. But if you were taking a multiple choice assessment, you're not going to see a negative n. So in this situation, because multiplying by a -1 or dividing by a -1 is the same, I was always taught to divide by a -1 here. Could multiply by the -1, but if we're dividing by -1, we get n equals a positive 15, like we did the first time. So just pay attention to that type of problem. They're not both negative. If the top and bottom of the fraction were both negative, then the whole fraction would be positive. Okay, so let's look at our next one. Don't freak out by this pi symbol. Pi is a number. It's approximately 3.14. So our unknown is x. And what operation are we to assume is between the pi and the x? Multiplication. So the inverse operation of multiplying by pi would be dividing by pi. And so on the left, inverse operations cancel, and you're just left with your x. On the right, you also have a pi. So again, inverse operations happen to cancel, and so therefore you're left with an answer of -2. All right, let's look at our next problem, 1.3z. And so just like pi in front of the x was multiplication, 1.3 in front of the z is also multiplication. So we're going to divide by 1.3. It's the inverse operation. And so we get z equals, and how many times does 1.3 go into 5.2? 4. Now, I didn't download it on this iPad yet. I will as soon as I'm done with this video. There is a online calculator that's a great resource that you guys can use if you don't have a calculator with you. It's called Desmos, Desmos. So if you go to desmos.com, you can get that calculator. It's free, and it's not a physical calculator. It's a calculator you can use on your phone or your desktop or your Chromebook, and it graphs. It's a really good resource. All right. Let's look at a couple more of these monitoring progress type problems. And if you want to, you could pause the video right now. You could pause, and you could try these on your own. All right. So, what's our unknown? Letter Y. And what operation's being done that we have to undo? Multiplication by, or division by 3. So we're going to multiply both sides by 3. And so that gives us y equals -18, because inverse operations cancel. Okay, next example. We have an unknown of x. So we want to use the inverse operation, division by pi. And like that previous example, these cancel just as they do on the other side, so x equals 9. All right. Next problem, we have 0.05w equals 1.4. And so the 0.05 is multiplying, you're multiplying by 0.05, so we're going to divide by 0.05. And so we have 1.4 divided by 0.05, and we get 28. And we could verify all of these answers by plugging back in. All right, so now we're going to look at solving some real-world problems. Students always struggle on reading type problems on the ACT, and a lot of it comes down to reading the problem and really understanding what the problem is asking. So don't hesitate to read a problem multiple times. Make sure you understand the unknowns and what it's asking you. make a plan, then solve the problem, then you can look back and make sure that it makes sense. Obviously, if we're talking about time or distance, it wouldn't make sense for the answers to be negative. All right, so here if we're looking at example 3, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. We want to write and solve an equation to find the average speed to the nearest 100th meter per second. And so we want to remember, and you may not have remembered this, you may be getting this for the first time, that the formula that relates distance and the rate of speed, r, and time is distance equals the rate of speed times time. And so it would be like distance would be, if we drove 5 miles an hour for 2 hours, we would go 10 miles. The rate of speed, 5 miles an hour, times time, gives us the amount of distance. If you're driving 60 miles an hour for 3 hours, you could go 180 miles. You may have done those kind of calculations when you've gone on vacation and you're trying to figure out how much longer you have to drive. And so, if we know that d, distance, equals the rate times time, and we want to know what is his rate of speed per second, then we need to get r by itself. And so, when you have two letters side by side, the operation is multiplication. And so we want to divide, use the inverse operation on both sides, so it's equal. And what we get is, on the right, the inverse operations cancel, leaving us with r. And on the left, there's no inverse operations, so we get d over t, distance over time. So our rate of speed can be determined by the distance divided by the time. Just like if I was to say, I went 200 miles in 4 hours. How fast was I driving? Well, the distance divided by the amount of time, so 200 divided by 4 is 50. So we would have been driving 50 miles an hour. So in this case, our r is going to be 200 over 19.32. And when we do that division, we get approximately, we want to remember this also, that little wavy equal sign represents approximate, because we're going to have to round this. And if we do this in our calculator, we get 10.35 approximately. And that is meters per second. And we can verify that by taking 10.35 meters per second times our amount of time, 19.32. And in doing so, when we multiply those, we get 199.96, which is approximately 200. All right. Let's look at one more example of this. So suppose Usain Bolt run 400 meters at the same average speed that he ran the 200 meters. How long would it take him to run 400 meters? Round your answer to the nearest hundredth. So how long would it take him? Well, he's running at the same average speed. So one thing you could do, relating back, because the numbers are so nice, from 200 to 400, it's double. It would make sense at an average speed, it's going to double the amount of time. So if we take that 19.32 and multiply that by 2, we get 38.64. All right. So the same would go if you took your 400 All right, guys, I hope you found this video helpful, and I look forward to seeing you next class. Remember to check the quizzes online and make sure you sign up on Google Classroom so that you can do your assignment.